Hello, Algebra 2. We are on our last day of notes, so 9.5 Arithmetic and Geometric series. So just make sure your notes are labeled, and we'll go ahead and get started. All right, so what is a series? The last couple days we've been talking about sequences, and a series is different because it takes the sum. So remember, sum means to add up, to make a total. So we're going to take the sum of all the terms that were listed in our sequence. So the last few days when we were just listing numbers in a sequence, now we're going to take all those numbers and add them together. So you're going to see the words arithmetic series, which is when you have an arithmetic sequence, you add up all those numbers. You're also going to see geometric series. So when you have a geometric sequence, you add up all those to make a series. So the difference between sequence and series is that with series, you add them all up. Okay, you add them all together. And with a sequence, you just list them all. So let's take a look at an example. The first one says, find the sum of the first 12 terms of the series. Okay, and then it tells you, well, here's your series. You start with -2, then go to 2, then go to 6, then go to 10. So what you're noticing is that in between each of these numbers, we're adding 4. Remember, when we add 4, addition, that means that we have a common difference, D. So our D is 4, and that makes it arithmetic. So I know that I have an arithmetic or arithmetic sequence, but now we are going to add up all those terms, which makes it a series instead of just a sequence. So when you guys look at your formula sheet, let's go ahead and take a look at it now. Down here, you'll notice here are all of our arithmetic formulas. For a sequence, we use this first one. For series, we can use one of these two last ones. So remember, n is how many terms we have. So in the example we are doing, we have 12 total terms. There's our n. A sub 1 is the first term in our sequence, and a sub n is the last or the 12th term for us. In order to use this formula, I would need to know the first term and the 12th term. In order to use this other optional formula, all I need to know is the n, the first term, the n, I already know, and the d. So think about which one I should use. Let's go back to my example. This first example, we have a D, we have the first term, but we do not have the 12th term. We don't have the last term. So it would make more sense for us to use that first formula. So go ahead and take a moment and write down the first formula, which is, or sorry, not the first one, the second one, this one right here. This formula, since we don't have a sub n, we don't have the 12th term. So I'm going to take n divided by 2, 2 times the first term, plus n minus 1 times d. Now that we know what formula to use, I'm going to move this a little bit, I want to go ahead and substitute in everything that I know. So I know that my n is 12, so let's go ahead and say the sum of 12 terms is equal to 12 divided by 2, and then 2 times the first term. My first term is -2. And then plus n minus 1, so 12 minus 1. And then multiplied by my difference. My difference is 4, and I'm going to go ahead and put that in parentheses because I'm multiplying. Then I'm going to close my brackets. And since I know every one of these variables, I replace them all. Let's go ahead and just simplify this. So 12 divided by 2 is 6. And then inside my bracket, I've got 2 times -2, which is -4. And then plus I have, oh boy, what's happening here? 12 minus 1 is 11, and then 11 times 4, so that's 44. All right? And I always simplify the brackets first. I have to move a little bit more space down. Oh, there we go. So -4 plus 44 is 40. So 6 times 40 will give me 240. All right. So if I add together the first 12 terms of this sequence, if it keeps going out 12 times, if I add all those numbers together, I'll get 240. On your paper, if you're following along with the packet, you have a number 2, but we're going to skip down to number 3. So you can try number 2 on your own. Number 3 says, for an arithmetic series, if the sum is 216 and the a sub n, so the last term is 34, you know n is 9, there are 9 terms, find the first term. So now let's go back and look at our formula. I know the sum, I know the last term, and I know n. So if we go back to our formulas, I know the sum, I know the last term, the a sub n, and I know the n. I'm trying to find the a sub 1. So for this example, this is a better formula to use because I do not know what the difference is. I don't know what the d is. So that's not going to be very easy. So these are 2 formulas that give you the same information, but you can use different pieces to find the sum. So we're going to use this one, n divided by 2 times this first term plus the last term. Go ahead and set that one up for yourself. So this one is going to be S sub n equals n over 2, and then you take the first term plus the last term. Okay, so what we are going to say is, well, I know n is 9, and then I'm going to have 9 divided by 2. I do not know the first term. That's what I'm supposed to find. That's kind of like my x here. And my last term is 34. And I also know that my sum of n, 9 terms, is 216. So I'm going to go ahead and write 216 is equal to 9 over 2, and then multiply that by a sub 1 plus 34. Okay, so this is now just turned into an equation that now I need to solve for a sub 1. So in order to do that, I am going to go ahead and get rid of this 9 over 2. So I'm going to multiply by 2 over 9. And we're going to multiply by the reciprocal. Okay. So this will cancel out. And now I'm going to come over here. All I have left is a sub 1 plus 34. And then what I'll have on the other side is going to be 2 times 216 divided by 9. So that will be 48. And then subtract 34. Okay? So all I'm doing is isolating my equation for a sub 1, which is the first term that I'm trying to find, because that's what the question asked me to do. So that gives me 14. Okay? So I started with 14. I added 9 every time. I added, what did I add? Oh, we still don't know what my difference is. But I have 9 terms. My last term was 34. And when I added those 9 terms together, I got 216. So for the last couple, you can do that for geometric or for arithmetic. What I want you to notice here is that this is an infinite geometric sequence. The only formula that you guys have that says infinite is the one with the little infinity symbol. So if you guys take a look back at your formula, you'll notice this one right here, and it's only under geometric, and it is the only one that has the infinity symbol. What that basically means is if you add enough numbers together in your sequence, will they eventually reach a place that you could just round it off to a certain number? Like kind of like an asymptote, right? When you get super, super, super close, you never quite get to the asymptote, but you can get really close that you could just round it off. So I could, and we know that our ratio is r, but it tells me that r has to be less than 1. The absolute value has to be less than 1. So in other words, I'm looking for an r value that can be between -1 and +1, because absolute value always takes into account negative and positive. So let's go back and write that on our paper. We know that for an infinite geometric sequence, it is your first term divided by 1 minus your r, but r has to be between, okay, because it's less than 1, absolute value is less than 1, which means r has to be between -1 and +1. Okay, so that means R could be 1/2. It could be 1/3. It could be 1/5. It could not be 2 or 3/2 or 5. It could not be any of those numbers. So let's see what's happening here. Find the sum for each of the following infinite series. So first of all, I have to make sure that my R is between -1 and 1. Otherwise, I can't even use this formula. So to get from 99 to 33, let's find what our ratio is. So 33 divided by 99 gives you 1/3. Okay, always take the second number, divide by the first number. So my ratio is 1/3. And ratio of 1/3, it does wind up being between -1 and 1. So great, that means I can use this formula. So the infinite sum series is the first term, so that's 99, divided by 1 minus 1/3. Okay, so 1 minus 1/3 is actually 2/3, right? So I can go ahead and say 99 divided by 2/3, and I wind up with 148.5. So if I added up, if I kept going and just kept dividing by 3, multiply by 1/3, go forever, eventually your numbers would get so small that when I add these all up, it's just going to get to one number. I'm not going to be actually going forever and ever and ever to infinity. They're going to get so close that I can round it off to 148.5. Okay? Let's check this one. Again, we have to find a ratio. So I'm going to do 4 divided by -2. And I get -2. The problem is our R is -2. Our ratio is -2, and that is not in the interval here. I can't use it. So this is not possible to do an infinite series, okay? I can't use my formula for this one because it won't work. Oop. All right? So I can only use one for this one. A works, B I can't do it for. All right, guys, last but not least, you are going to see this symbol a few times throughout this unit. And the reason is because all it does is tell you guys another way of saying sum. So sigma notation, sigma is this symbol right here. And it is the Greek letter S. You guys have already learned a few Greek letters this year. But the big S in Greek is called sigma. And what it means is sum. Just like the word series, this also means sum, okay? So think series when you see this big sigma. All it's telling you to do is take this little expression, 3n minus 5, and whenever you have a variable like n, you're going to want to substitute in a number for the variable. So we are going to start by substituting in 2, because you'll notice that right here, under the sigma, it says n equals 2. So that's how I'm going to start. But I'm going to do that until I get to 5. So my 5 is like my stop button. So I have a start button and a stop button. So here we go. I'm going to say 3 times 2. That's where I start. Minus 5. A sum means I add. So now I'm going to do it again, but now I'm going to go to the next number. 3 times 3. Minus 5. Again, sum means add, so I'm going to do it again for the next number. 3 times 4, minus 5. Again, now it says 3 times 5, minus 5. Okay? My writer is not working very well. There we go. Now, I stop there because it says to stop when you get to 5. So I substituted in 2, 3, 4, 5. But I stopped there because it said to stop at 5, and I started with 2 because it said to start with 2. So now I'm done setting it up, and now I can just simplify. 3 times 2 is 6, minus 5 is 1. 3 times 3 is 9, minus 5 is 4. 3 times 4 is 12, minus 5 is 7. And then 3 times 5 is 15, minus 5 is 10. So if we add all those up, I get 17, 18, 22. So using sigma notation is just another way for you to basically be writing a series. Go ahead and try to set up these 3, and we will check them tomorrow.